On the AFOQT, you'll need to distinguish between two core sets of FAA regulations for pilot training, Part 61 and Part 141. Part 61 is known for its flexibility, allowing a student to train with an independent instructor on a self-paced schedule. This path is ideal for those balancing training with other commitments. In contrast, Part 141 governs FAA-approved flight schools that use a structured, pre-approved curriculum. These schools are subject to regular FAA audits and often provide a more accelerated path to certification, sometimes with lower minimum flight hour requirements. An exam question might describe a student who wants to learn flying on weekends. This scenario points directly to the flexibility of Part 61. Conversely, a university aviation degree program would operate under the strict framework of Part 141. The common trap is mixing them up. Remember, Part 141 is for structured schools, while Part 61 offers greater freedom. Next, you must master the difference between a METAR and a TAF. A METAR, or Meteorological Aerodrome Report, gives you the current weather at a specific airport. It's a snapshot of what's happening right now. A TAF, or Terminal Aerodrome Forecast, provides a weather forecast for the next 24 to 30 hours for the area around an airport. The AFOQT will test this distinction. For example, if a question asks what a pilot should check to know the weather for a landing in 6 hours, the correct answer is the TAF, not the METAR. The trick is to associate METAR with the present moment and TAF with the future. A critical aviation concept tested is density altitude. Density altitude is pressure altitude corrected for non-standard temperature. Think of it as the altitude the aircraft feels it's at. 3 factors increase density altitude: high elevations, high temperatures, and high humidity. High density altitude means the air is less dense, which severely degrades aircraft performance. It leads to longer takeoff rolls, reduced rates of climb, and decreased engine power. An exam question will likely present a scenario, such as a hot day at a mountain airport, and ask about its effect on performance. The answer is that performance will be significantly reduced. The trap is forgetting that hot, high, and humid all work together to create a high-density altitude, which is bad for performance. Finally, a straightforward but essential point is how cloud bases are reported. In aviation weather reports like METARs, cloud bases are always measured in feet above ground level, or AGL. This tells a pilot their actual height above the terrain below, which is critical for safety, especially during takeoffs and landings. The exam might show a coded report like OVC 025 and ask for its meaning. This simply means an overcast layer at 2,500 feet AGL. Don't confuse AGO with MSL, or mean sea level. To remember the difference between the two main weather reports, use this phrase: METAR is for the moment, but a TAF is for the time ahead and future. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.